All right, we've got the last lesson for Unit 1. This is lesson 1.3.2. We're going to look at zero and negative exponents. In the previous lesson, we were just talking about expanding exponents so that we could kind of figure out if we're supposed to, how we're supposed to combine the different exponents of the like bases. So you might have been expanding the whole time. Or you might have, looked at your work and said, hey, there's probably some quicker ways to do this, and you might have started doing those, and that's great if you did. Because what we're going to talk about today is how to kind of generalize some of our observations about how exponents work. So we're going to kind of come up with some rules about this. But the first thing I want you to do is just kind of go back to what we did last time and do these 6 problems. So I'm going to give you a few seconds to do it. I'm just going to pause this. So go ahead and pause your screen and do these 6 problems for me real quick. All right, so I'm going to pause in 3, 2, 1, then I'll be right back. All right, I am back. So here's my answers. My first one, I saw that I had 7 of the 4's being multiplied, and 7 of the x's being multiplied and 4 of the x's being multiplied. So that's a total of 11 x's being multiplied. Next one, I broke this one down into x to the third times x to the third times x to the third. So now I can see that there are 9 x's there. So x to the 9th. Over on this one, I split up the m to the 14th into m to the 2nd and m to the 12th. And then using the big 1, I can get rid of the m to the 2nds because they make 1. So I'm just left with m to the 12th. On the next one, I combined the 4 x's that are inside the parenthesis. So that became x to the 4th, and then it's to the 4th power. So that means that there are 4 x to the 4th, which means there's 16 x's. And then on the next one, I split up x to the 5th into x to the 2nd and x to the 3rd. And then I have an x to the 2nd on bottom, so there's a big 1. For the y's, I split up the top into the numerator into a y to the 3rd, y to the 8th. I've got a y to the 3rd on the bottom, so that's a 1. So after these 1s, what am I left with? X to the 3rd, y to the 8th. For the last one, I had 2 in the numerator. The denominator was 8, so I changed that into 2 times 4, so I could have this big 1 here. And then for the x's, in the numerator, I changed it to x to the 2nd and x to the 12th. And then I was able to pair up that x to the 2nd with the x to the 2nd on the bottom, so that's a big 1. So we got to kind of get rid of that. Now I'm left with is an x to the 10th on in the numerator and a 4 in the denominator. So our final answer would be x to the 10th over 4. A lot of people on this problem will accidentally write 4x to the 10th. This is why it's nice to kind of show it like this, because you can definitely see that the 4 is in the denominator and not in the numerator. So you have to check for that. All right, so what we're going to do now is we're going to kind of come up with some kind of generalized rule for these. And you might have seen the rule already. You might have been using the rule already. In general, what we saw here is in multiplication, I have 25 x's here and 40 x's here. So what have we been doing? We've been adding those together. This would be x to the 65th power. So our general rule, where we don't actually have numbers, we just have variables, it looks like we should be adding the 2 exponents together as long as the bases are the same. So this is a base of x, this is a base of x. So we would know that this is x to the m plus n. So what we notice is when we expanded it, it was telling us how many x's we have. And so if we've got 2 different things that both have x's, then we can just add the x's together. So when you expand, or when expanding, the exponents tell us how many x's we have, so we add them together. All right. And let's say that we're looking at division now. So we're dividing. I've got 36 x's in the numerator, and I've got 13 x's in the denominator. And maybe you've noticed, but what we've been doing is subtracting those two numbers. So this would be x to the 36 minus 13, which would be 23. So it looks like in general, the denominator is being subtracted from the numerator. So our general rule is that we do m minus n. So take the numerator's exponent and subtract out the denominator's exponent. Okay, so what we notice is that when we do these problems, we're reducing the bases, or reducing the exponents. So we are subtracting. It's supposed to be a B. All right, last one. These are called powers of a power. And we talked about this one is this means that there are 12 x to the fifths. So this is telling me how many times I'm going to have x to the fifth. So in this case, I would have 60 of them. So this one out here is telling us how many times. That's multiplication. So this is going to be x to the m times n. So a power to a power tells us how many times, I'm going to put in parentheses, how many times means multiplication sometimes, right? How many times we have a variable, so we multiply. Now the easiest one to get confused is multiplying and powers to a power. So at some point you'll probably be confused and not quite sure what to do. Expand it. If you ever get into a jam where you're not quite sure what to do it, if you expand it, it should explain what you're doing. All right, now we're going to look at something else. So I got three generalized rules that we've come up with. Multiply, we add the exponents. Dividing, we're subtracting the exponents. Power to a power, we are multiplying the exponents. Now what about negative exponents? Now we just said that the rule for dividing was to subtract them. So let's look at this problem. And it's saying to subtract them. So I'm going to do x to the 4 minus 5. X to the 4 minus 5, 4 minus 5 is negative 1. So this is x to the negative 1 power. Now let's look at how we would have done that problem using our other lessons. So I would have done x to the 4th on top, numerator. On the denominator, I put x to the 4th, and then I'd have another x to the 1st. And then we could see that this is a big 1. And I'd be left with 1 over x. All right, let's do the next one. Next one, we would do x to the 2 minus 4, which is x to the negative 2. Doing it how we were doing it the other day, we'd do x to the second on top in the numerator, x to the second in the denominator, and then x to the second. So we've got a big 1 right here. That was the worst one I've ever done. And we see that this is, oh wait, x to the 4th is supposed to be on the bottom. Oops. So I get 1 over x to the second. All right, next one. I've got x to the 7 minus 10, which is x to the negative 3rd. Okay, doing it the old way, we would have done x to the 7th in the numerator, x to the 7th in the denominator. And then I still have 3 more x's in the denominator. So this is x to the third. And our big 1 comes from over here. So that equals 1 right there. And I'm left with x to the 1 over x to the third. All right, so what have we noticed? We've noticed that x to the negative 1 is actually 1 over x, because we solved the problem 2 different ways and got these 2 answers. So it looks like a negative exponent means that this is 1 over x. When we had x to the negative 2, we found out that's the same thing as 1 over x to the second. When we had x to the negative 3, we found out it's the same answer as 1 over x to the third. So what we're seeing here is that negative exponents are reciprocals. So let's write that down. So our generalization of this is that if I've got x to the negative n power, that should be 1 over x to the n. Notice that the negative power goes away once you put it in the denominator. Now conversely, I could also say that since negative exponents are reciprocals, if I had 1 over x to the negative m, then if it's a reciprocal, this would just be x to the positive m. See, the denominator moves to the numerator. So if I've got something in the numerator with a negative exponent, it goes to the denominator. If I've got something in the denominator with a negative exponent, it moves up to the numerator. All right, so that's negative exponents. Let's look at 0 exponents now. For 0 exponents, I want to just kind of look at something that looks like it's pretty obvious, but it'll kind of give us some good ideas here. This one says 4 divided by 4, and I know that is 1. Now another way to think of 4 divided by 4 would be 2 to the second divided by 2 to the second. Now since it's still 4 divided by 4, I know that answer is still 1. But wait, let's use our exponent rules. Our exponent rules are that when we divide, we're supposed to subtract those. So if I do 2 to the 2 minus 2, because I'm supposed to subtract them, I get 2 to the 0 power. What's this telling me? It's telling me that 2 to the 0 is 1. 2 to the 0 power is equal to 1. All right, let's look at x's now. I've got x divided by x, and we know that answer is 1. Now I've got x to the 5th divided by x to the 5th. Well, they're the same thing, so I know that answer should be 1. But let's go ahead and use our exponent rules. So I'm going to do x to the 5 minus 5. And that ends up being x to the 0 power. So again, I'm finding out something to the 0 power is equal to 1. And in fact, we actually know that anything to the 0 power is 1. Let's go ahead and look at a different way to look at this so that we can kind of see why something to the 0 power would be 1. Let's start with, how am I going to do this? Let's do, I like this color, so I'm going to go with this one. Let's start with 3 to the 1st power. All right, 3 to the 1st power is 3. I think we would all agree with that. 3 to the 2nd power, 3 times 3 is 9. 3 to the 3rd power, 27. 3 to the 4th power, 81. Now ask yourself, when we increase the exponent, what's happening to these values down here? Well, it looks like we're multiplying by 3 each time, right? So from here to here, we are multiplying by 3. From here to here, we are multiplying by 3. And my pen's trying to ink. Let's go with, there you go. We're multiplying by 3. From here to here, we're multiplying by 3. So it looks like when I'm going from left to right, Each time I increase the exponent, I'm multiplying by 3. What if I wanted to go from right to left instead? If I want to go from 81 to 27, what am I doing? Well, this direction I was multiplying by 3, so going backwards, I must be dividing by 3. And going backwards here, 27 divided by 3 is dividing by 3 again. And 9 divided by 3 is 3, so I'm dividing again, going that direction, going towards the left. So 3 to the 0 power, I should, to find 3 to the 0, take this and divide by 3. What's 3 divided by 3? It's not 0, it's 1. So going this direction, I'm dividing by 3. Now the next number would be 3 to the negative 1 power. And what's the rule going this direction? We're dividing by 3. So what's 1 divided by 3? It's 1/3. See, negative exponents are fractions. And if I kept on going, 3 to the negative 2, I'm going to take this and divide by 3, and I would get 1/9. So this is 1 over 3 to the second. So going forward, you multiply by 3, and now going backwards, dividing by 3, we can see why anything to the 0 power is 1, and we can see why negative exponents are fractions. All right, so it's time for a little bit more practice. Let's see if you know what you're doing. All right, so I've got these 3 problems right here. I want you to go ahead and try them out on your own. Just get a few minutes. If you get stuck, that's fine. I'll come back and show you how to do them. But I want you to take a break. All right, or not to take a break. I'm going to take a break. You're going to do some work. All right, and in 3, 2, 1, I'm going to pause, and then I'll be right back. All right, we're back. I forgot to tell you right before we left. When we simplify exponents, your final answer is not allowed to have negatives in it, and it's not allowed to have 0. So negative exponents and 0 cannot be in your final answer. So if you left the first one as 3/5 x to the negative 3y, you're pretty close. You just need to move the x to the third to the denominator because it was a negative exponent. So I took the 18 and the 30 and reduced them both by 6. So I got 3 over 5 from that. And the x's, I did 2 minus 5, which makes negative 3 power. And then since the y to the negative 1 is on the bottom, that's a negative 1 because we subtract the denominator. So that's y to the first. So my final answer is 3y in the numerator, because y is a positive exponent, and 5x to the third in the denominator. On the next one, I multiplied negative 5 times negative 2. Now those negatives do not mean that you switch or put one in the denominator or anything like that. Those are just negative numbers. It's only negative exponents that mean they're reciprocals. So negative 5 times negative 2 is positive 10. And then I did x to the negative 2 plus 3 and y to the 1 plus negative 2. So I ended up with x to the first, y to the negative 1. And so since y is a negative exponent, I put that in the denominator at the end of the problem. This next one, I moved this x to the negative 3 to the numerator first. So that x to the negative 3 went to the numerator. And then I got 15 over 45, which reduced by 15. And then in the numerator, I moved the x to the third up there, and I had an x to the second in the denominator from this one right there. And if I subtract those, I get x to the first. So that's a positive exponent, so it belongs in the numerator. So I get x over 3. All right, our last problem is a little bit of a tough one. We might need a calculator on this one. It says that a size 7 shoe is about 1.4 times 10 to the negative 1 meters long. So in meters, that's not a lot of meters because it's a negative 1 means it's a small number. Okay, and then it says the circumference of the Earth is about 1.06 times 10 to the 7th power. Now that's a big number. It means that there's 7 decimal places that need to be added to this one. So that's a big number. And we want to know how many shoes end to end are going to be able to fit around the equator. Okay, so I want to know, I got this equator and how many of these shoes will fit around it. Well, it looks like we need to find out how many shoes will go into this number. So that's a division problem. All right, so I've got 1.06 times 10 to the 7th. And I'm going to divide by all those shoes that are going into there. So that'd be 1.4 times 10 to the negative 1. Okay, I'm going to need a calculator first. Let's look at those coefficients, the 1.06 and the 1.4. So I'm going to take 1.06. Let's see. Here, 1.06 and divide by 1.4. I get 0.757. So this gives me 0.757. And then we're going to do times 10. And what are we supposed to do with these exponents? We're supposed to subtract them. So this is 7 and then minus negative 1. But a negative 1 is actually 7 plus 1. So I end up with 0.757 times 10 to the 8th power. Now, question, is this proper scientific notation? Answer, no, it's not, because our first integer needs to go in the ones place. So this 7 needs to be moved over there. So how can I rewrite 0.757 if I move it over? So 7.57. So that's what it needs to look like. Well, how did I do that? I did that by changing this with a negative. So this shows that it's a small number. So I need a negative exponent because I just made it bigger. So if I make it bigger on one part of it, I need to make it smaller on the other one to make it balance out, right? So 0.757 is the same thing as 7.57 times 10 to the negative 1. And then over here, I've got 10 to the 8th power. So not 0, 8. So I've got negative 1 and 8. I'm multiplying, so I should just add those. So I get 7.57 times 10 to the 7th power is my final answer. So that's how many shoes it would take to fit around the world. In case you were planning on doing that, you now know how many shoes you're going to have to go buy. All right, last thing is our learning log. You're going to want to, at this point, go through your rules for exponents and put them in there. This is actually in the methods and meaning section. So if you want to just kind of write these rules in your own words, that could work as well. But I just want you to write out all the rules for exponents. You know, what happens when you multiply, what happens when you divide, powers, negatives, zeros. Get all your rules all in one place so that when you do get to a point and you're like, how did we do that 2 weeks ago? You just have somewhere that you can look back at really quick, and it has all your rules for exponents. So I want you to write out over here in your learning log all the rules to exponents. All right, that's all I got for you today. You are done with Unit 1. Congratulations. Bye-bye.